Equilibria, the word you always hear and forget the letter I while you are writing it. You know surely what it means, but do you know how it's related to your electrical car battery? Today, I will be talking about how batteries work, galvanic cells, redox reactions, Nernst equation, equilibrium, and its battery point of view. Let's dive into it. Let's talk a little bit about batteries first. A battery converts stored chemical energy to electrical energy by oxidation reduction reactions, which is also called redox reactions. Since, why not? Electrons occurred from oxidation reactions at anode gets transferred to cathode to be used in the reduction reaction of other metal. Since there is electron flow, there will be an electrochemical potential generated. If we connect the device to the electron's way, the device will be powered by the electrochemical potential generated. In order to calculate how much voltage is generated, an equation called Nernst equation can be used. If we omit the standard electrochemical potential, temperature, and a bunch of constants, we can focus on this cute letter Q here. But before talking about Q, let's define equilibrium first. Equilibrium means that the forward reaction rate is equal to the backwards reaction rate. You can imagine yourself in a shopping cart driving into a hole.
Please keep your hands and arms inside the vehicle.
If your cart is moving, your reaction is progressing forward or backward, but if your cart stops at the bottom, it's in equilibrium. Now, Q is called the reaction quotient. It is given by the concentration of the products, each raised by its coefficients over the concentration of the reactants, each raised by its coefficients. So the current situation of your cart is called Q. When equilibrium occurs, however, Q magically changes to K, which is called the equilibrium constant. There are lots of details like solid phases count as one, and with gaseous phases you have to use pressure, and standard electrochemical potential can change, but let's now focus on the batteries. We have a lithium-ion battery pill which is being frequently used in any portable electronic device. At start, we are on the hill, so our battery is fully charged. Our friend pushes our car and reaction starts to go forward and consume the energy stored in battery. As Q comes closer to K value, reaction slowly starts to come to the equilibrium. When it is in the equilibrium, since there is no electron flow, the battery is finished and you cannot use your device anymore. Balance is maybe a good thing for your life, but for a battery point of view, balance is bad. In order to break this balance, one can charge the battery from an external source by taking your cart to the hill. It is the reaction is now going in backwards and electrons are stored at anode for another round of fun car adventure. Don't forget, there are lots of things you can learn from thermodynamics and shopping carts. As always,